Hello everyone, welcome to our very first tutorial for Biochem 217. I am Deyabu Musbawa, as you all know. I will be taking you this course also, and this is also one of the most interesting area of biochemistry. And in today's class, we will start with the introduction, definition, function, classification, and chemistry behind the lipid. So as you can see here, this is chemistry of lipid. Despite that there is no introduction here, it's just definition of lipid. But as you can see here, lipid are organic compounds formed mainly from alcohol and fatty acids combined together by ester linkage. So as we say in our course content today, we have to start with introduction. So lipids, introduction to lipids are great importance to our body. Lipids also, they are of great importance to our body. So they provide energy and they play important role in cellular structure and various other biochemical functions, such as such lipids are heterogeneous group of compounds, and therefore it is rather difficult to define them precisely. So we regard lipid, we say lipids may be regarded as organic substances that are relatively insoluble in water but soluble in organic solvent. What are organic solvents? Example: alcohol, ester, benzene. So lipids are soluble in water, but they are soluble in organic solvents. So even if they are soluble, some that are soluble, they are relatively soluble, not soluble at all. So actually, all potential related to fatty acids are utilized by all living cells. Yes, they are utilized by all living cells. And we say, unlike we explained carbohydrate and protein. So unlike the polysaccharide, that is carbohydrate that contain multiple mono units, protein and nucleic acid, lipid are not polymer. They are not polymer. Lipid are most likely small molecule, but they are not polymer like protein and carbohydrates. So let's start with this slide that we are seeing now. Lipids are organic compounds found mainly from alcohol and fatty acids combined together by ester linkage. So when you have a fatty acids plus fatty alcohol by esterase, that is the enzyme that link lipids together. As you can see here, this is the fatty alcohol, this is a fatty acid linked together by ester bond, then give you lipids. This is lipid, or we say ester, but we are going to see them later, not now. This is just a example. So as you can see here also, when you have a glycerol, this is glycerol, is a sugar, and this is fatty acid. So combined together give you triglycerol. This is also just example. We are going to see them one by one in our later lecture. You can see here, lipid are insoluble in water, we said before, but soluble in fat or organic solvent. Example: ester, chlorophene, benzene, acetone. Example of lipid are fat: butter, ghee, lard, tallow, terpenes, and steroid. These are the example of lipid. So as you can see here also, that are also example of lipid. Vegetable oil such as olive oil, corn oil, soybean oil, and the rest. They are widely distributed in nature, both in plant and animals. So next, we are going to see the function of lipid, that is biological importance of lipid. Lipids are source of energy. Yes, lipids also provide energy, but they don't provide energy like carbohydrate, but also provide energy when it's needed. They are carrier of vitamin A, D, E, and K. Number 3, structural function. Phospholipid and glycolipid enter in the construction of the plant cell, where we are going to see how phospholipid and sphingolipid in plant cell ways. Despite that you don't know what mean by phospholipid and sphingolipid, but we are going to see all of them later. They are example of complex lipid under class of lipid. Number 4, protective coating, such as wedges, that are important as protective, cover the tissue of plant and some animal, that is wedges. So as I said earlier, lipids are insoluble in water. That is why they speak the lipid. When part speak, part said, with water I say, touch me, no. With tongue I am tasteful. With limits I am dutiful. In excess I am dangerous. So see, when you have a lot of fat or lipid in your body, you become weak. So that is why lipid talk say, in excess I am dangerous. Then the next one, I said we are going to see the classification of lipids. So lipids are broadly classified into simple, complex, derived, and miscellaneous lipids, which are further divided into different groups. Example: we have simple lipid, first one, that is ester of fatty acids with alcohol. So when a fatty acid is joined with alcohol, give you simple lipid. And they are also of two types. We have fat and oil, that is triacylglycerol, or you can say triglycerol, all the same thing. They are ester of fatty acid with glycerol. The difference between fat and oil is only physical. Thus, oil is a liquid while the fat is a solid at room temperature. You know oil that you are using, and you know fat, all of you. So fat and oil, we call them triacylglycerol, or we call them triglycerol. It's all the same thing. So, and the only difference between them is physically. That is, this one is liquid and this one is solid at room temperature. Then B, what is that? Ester of fatty acids, usually long chain with alcohol, other than glycerol. You understand? This is the fat and oils is ester of fatty acid with glycerol, while wedges are ester of fatty acid, usually long chain with alcohol other than glycerol. This alcohol may be aliphatic or alicyclic. You all know the difference between aliphatic and alicyclic in your organic chemistry. Alicyclic containing an aliphatic straight chain. So alcohol is the most common found in bodies. So then number 2, we have complex lipid. Number 1, we say we have simple lipid, and number 2, we have complex lipids, or we say compound lipid, all the same. These are ester of fatty acid with alcohol and contain additional functional group such as phosphate. That is when you have compound lipid such as phosphate, nitrogenous base, carbohydrate, protein. We have talked about phospholipid, glycolipid, and the rest. So all they are under complex lipid. So the complex lipids are further divided into the following. We have phospholipid. They contain phosphoric acids and frequently a nitrogenous base. This is in addition to alcohol and fatty acids. You have alcohol in phospholipids, you have fatty acids, and also they contain phosphoric acid and frequently a nitrogenous base. We are going to be touching them one by one. That's why now I am just explaining. We are going to see them one by one. Don't say I did not say anything about them. Then we have glycerophospholipid under phospholipid. We have sphingophospholipid also under phospholipid. This phospholipid contain, for glycerophospholipid, they contain glycerol as alcohol. We have example lecithin and cephalin. And sphingophospholipid, also the alcohol is in this group of phospholipid. The sphingosine is the alcohol. So we have sphingomyelin. This is where the cell membrane. This is inside the cell membrane. Then we have glycolipid. This lipid contains a fatty acid. That is after phospholipid. We have glycolipid. This lipid contains a fatty acid, carbohydrate, and nitrogenous base. The alcohol is sphingosine, right? Hence, they are also called as glycosphingolipid. Glycerols and phosphates are absent, e.g. cerebroside and ganglioside. We are all going to see all this. You are going to see their structure and everything. Then under glycolipid we have lipoprotein, macromolecule complex of lipid with protein. That is a lipid with protein we call lipoprotein. Then we have other complex lipid. It is phospholipid, aminolipid, and lipopolysaccharide. When you say sulfolipid, it contains sulfur. Then aminolipid contain amino acids. Lipopolysaccharide contain sugar, and among others complex lipid. Then we have dry lipid. These are derivatives obtained on the hydrolysis of group 1 and group 2 lipid, which possess the characteristics of lipid. These include glycerol and other alcohol, fatty acids, mono and diacyl glycerol, lipid, that is fat soluble vitamin. Then we have, it contains sterile homer, hydrocarbon, and ketone bodies. We are all going to see them. It's just that I am introducing you to lipid chemistry. Then we have miscellaneous lipid. Miscellaneous lipid. This one I don't think they're going to teach you, but this one is not under your course content. I don't think, but maybe you are going to touch it also. So we have neutral lipid. The lipids such as on chart are referred to as neutral lipid. These are mono, di, and triglycerides, cholesterol, and cholesterol ester. So we have seen these are the classification of lipids that we are going to. This is all about lipid. We are going to be doing is under all this I mentioned. So I think this is all what we will do today. So as I said, the last thing that we are going to be seeing today is chemistry behind it. That's chemistry behind the sleeping. So let us take fatty acids and use this as example and see the chemistry behind it. Fatty acids are carboxylic acid with hydrocarbon side chain. So, and they are also the most simplest lipid we have. Example, we have palmitic acid with 16 carbon. We have stearic acid with 18 carbon. They are the most common acid that we have. And among the old chain, we have propionic acid with 3 carbon. We have valeric acid with 5 carbon, I think. And we have monounsaturated fatty acid, and we have polyunsaturated fatty acid. A monounsaturated fatty acid is a fatty acid that contains no we have a saturated fatty acid, we have monounsaturated fatty acid, we have polyunsaturated fatty acid. A saturated fatty acid is fatty acids that contain no double bond. A long chain of fatty acid with no double bond. And we have monounsaturated fatty acid, a fatty acid that have a single bond between one carbon of the fatty acid to another. Then we have polyunsaturated fatty acid. A polyunsaturated fatty acid is a fatty acid that have one or more double bond. So, as we said also, this is the typical structure of fatty acid. CH3, CH3, CH2, CH2, let's say we have COOH. I think this is all about saturated and unsaturated fatty acid. A fatty acid that contain no double bond, and a fatty acid that have a double bond. So now we are going to talk about We are going to talk about a fatty acid with glycerol and fatty acid. So we have seen the chemistry behind fatty acids. Now we are going to see the chemistry behind glycerol and fatty acid. If they join together, what we are going to get. So this is a typical example of glycerol. We have 3 carbon. This is glycerol with OH, 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 H here, H here. We have H here also. We have H here. We have also H at the bottom. So as you can see here, we have glycerol here. We have glycerol here. This is glycerol here. When glycerol join together with 3 fatty acid, this is a typical example of glycerol. That's structure of glycerol, and this is 3 fatty acid. Let me draw it, just see it how I draw it. Let's say we have glycerol here and plus 3 fatty acid. As I said, this is fatty acids, right? Double bond OH. Double bond OH. R, C, double bond to oxygen, then carbon double bond to oxygen, then carbon single bond to OH. This is a typical example of glycerol. You know what mean by this R bar? It can be 1, 2, 3, 4, 5, 6, 7, up to 10 carbon, 20, 30, up to where you can stop. So that's the meaning of this R. So if you combine glycerol, this is glycerol, I say. So if you add fatty acid with glycerol, it will give you you are going to get glycerol. If you have fatty acid with you are going to get monoglycerol, fatty acid with a glycerol with 1 fatty acid will give you 1 monoglycerol. When you join, you have glycerol at carbon 1, and a fatty acid with a glycerol with 2 fatty acids will give you 1,2 diglycerol. A fatty acid with 3 glycerol. A glycerol with 3 fatty acids will give you triacyl glycerol, or you say glycerol, triglycerol. Let's see how it's gonna be. This is our glycerol, right? We have glycerol here. We have glycerol here. We have glycerol here. If you carry 1 fatty acid, let's say we carry this C double bond to oxygen, then R. In this example, I have a question. What did we eliminate here? I have a question. What did we just eliminate here? We eliminate something here. So this is 1 monoacyl glycerol, or you can say 1 monoglycerol. Just say 1 monoacyl glycerol. It sounds very clear. When you have it at carbon 2, when you have your glycerol at carbon 2, let's say we have OH here, then your glycerol come at carbon 2. We have 2 monoacyl glycerol. When you have your glycerol at carbon 2, we have 2 monoacyl glycerol. When you have your glycerol at carbon 1 and carbon 2, when you have your glycerol at carbon 1 and carbon 2, then we have another one here, C double bond oxygen. R group. This is R1, this is R2. We have, let's say we have OH here. We have 1,2 diacyl glycerol. This is a chemistry behind fatty acids and glycerol. And when you have 3 fatty acid group, C double bond to oxygen, then R3. This is where you have triacyl glycerol, 1,2, 3 triacyl glycerol. But you don't have to mention the numbers because everybody knows that glycerol has only 3 carbon atoms. So just say triacyl glycerol. So I think this is all we have for today. Try to watch the video and answer the question, what did we just eliminate? We have eliminated something here. We add 3 fatty acids to glycerol. So in each reaction we eliminate something. What did we just eliminate? Please try to answer this question. So I think, guys, for today this is all what I have to say about fatty acid, about lipid. Then this is just introduction to lipid. We are going to take them as I mentioned. I mentioned all of what will be doing: glycerol, fatty acid, phospholipid, glycolipid, phosphatidycholine, phosphatidyethanolamine. All of them we are going to see them one by one. So try to watch video and understand. Then we are going to have a discussion about this lecture and yesterday on tomorrow. I am still going to open the group. Today for those that have a question before the general discussion tomorrow. Thank you all for having you here.